Okie dokie, number 11, A and B is graphing rational functions. I'm going to walk through the steps. I'm not actually going to graph them for you, though, because I don't have any graph paper on here, and I don't feel like making a terrible drawing. All right, so we're just going to start with A. Again, you had, what, 5 or 6 steps that we kind of went through. You want to find any holes, you want to find any y-intercepts, zeros, horizontal asymptotes, vertical asymptotes, slant asymptotes. And then, honestly, once you find all that information for me, then really all you're going to do is plug your equation into your calculator and sketch it off of that. Let's do y-intercept first for that one. Remember, for the y-intercept, all you're going to do is plug a 0 in for the x. So 0 squared minus 2 times a 0 minus an 8 over 3 times a 0 minus a 9. You get a negative 8 over a negative 9, which is a positive 8/9. Okay, let's do any holes that we might have. And when you're doing any holes that you might have, you're looking for things that cancel, but you're going to have to factor first. The numerator is going to factor to an x minus 4 times an x plus a 2, right? Yeah, okay. And then the denominator just factors. You get a GCF of 3, so that factors out of there. There are no holes. Nothing cancels, right? And there are no common factors, so we got 2 things down. 1, 2, check. All right. Let's find x-intercepts. For x-intercepts, you always just take your numerator and set it equal to 0. And since I had already factored this one that I'm going crazy with the laser pointer on, I'm going to use that. And from that, when you set that equal to 0, I'm not going to show you the work because the work is actually already shown on the paper key. You get an x equals a 4 and an x equals a negative 2. And so, of course, it would be 4, 0 and a negative 2, 0 when you go to graph it. You're going to do vertical asymptotes, and vertical asymptotes are the denominator, right? Your denominator cannot be 0. So again, and I'm going to write this out because I feel the need to kind of write this out, guys. So we got y-intercept, we got no holes, we got our zeros. When you go to do the vertical asymptote, this 3 doesn't do anything, guys. You're going to divide by 3, it's going to disappear. But a lot of us, sometimes we think that, and let me change that. I didn't want to write an x there because you're going to think it's an x. Sometimes we think we have to write like 3 equals 0, and that's not a true statement. There's nothing happening there. So just kind of ignore that 3. So you get a vertical asymptote at x equals a positive 3. And you have to write it as x equals a 3 because it is a vertical line. Okay? All right, so there's vertical. So that's steps 1, 2, 3, and 4. The 5th step was the horizontal asymptote, and you had to remember your scenarios. If your, and I'm pointing real, it's still really tiny. You're looking at exponents. You're looking at the degree of your numerator, degree of your denominator. So if the degrees were equal, so if it was like x squared over x squared, you would just take your leading coefficients. If the numerator was less than your denominator, then you would, sorry about that, then you would, y equals 0 is your horizontal asymptote. The degree of the numerator is 1 greater than the degree of the denominator. So not only do we not have horizontal asymptotes, okay, so that's that step. We also have a slant asymptote because it is exactly 1 greater than. So I'm going to shrink everything. Oh, maybe I'm going to shrink everything. There we go. Shrinking and shrinking so that I can go through and do our division. Now, you have some options to do this. You are really just taking x squared minus 2x minus 8, and you are dividing it by a 3x minus 9. And you can do this with long division. Right? And what you would need is a 1/3 x here, because 1/3 times the 3 gives me a 3, and x times x gives me x squared. And then 1/3 x times a 9 gives me a, well, times a negative 9 technically, is a negative 3x, right? When I do that. And then you are subtracting here, right? So x squareds are going to go away. I have a negative 2 times a, I'm sorry, negative 2 plus a 3x. So I get an x, bring down your 8, okay? And then you're really just going to write a plus 1/3 there, okay? And so then when you do, and I'll do it in separate, when you do 1/3 times the 3x, you get your x, and I've run out of space. So let me make it a little smaller. There we go. Okay, you get your x, and then when you do 1/3 times the 9, you get a 3 there. And you subtract, and you end up getting a remainder of -8 plus -5. You don't care about the remainder. You really only care about the equation. Y equals 1/3 x plus 1/3. That is the equation of your slant asymptote. You can also do this with synthetic division, right? But what you're going to actually divide by, 3x minus 9 equals a 0. You solve that, you get x equals 3. When you go to do your division, the 3 is what's going in the little box, right? But ultimately, you will have to divide everything by 3 when you get that. So 1, -2, and a -8. Okay, so bring down your 1. 3 times 1 is 3, -2. That doesn't make sense. Where's my signed error? -2 plus 3. Oh, no, that's fine. That's a 1. So 3 times 1 is a 3. -8 plus 3 is -5. So you see that you get the same remainder, but here's the deal. These two things, it's not going to be, your equation isn't going to be 1x plus 1. It's going to be 1/3 x plus 1/3. I know that's a little kind of sloppy down there. Because you had your leading coefficient here was 3. Okay, so it's almost faster and easier to just do the polynomial long division, especially if you're not going to remember that you have to then go divide by 3. All right, that's 7 minutes. I'm going to make a separate video for the next one.